In the previous video, we learned 10 rules of writing clean code. Today's video will introduce 10 more rules. So without further ado, let's start the video with rule number 1. Rule number 1. Avoid magic numbers. In the reload method, we are setting the current ammo variable to 20. This is an example of a magic number. There is no indication what this number means. Whenever we see such situations, we should change such a number to a variable. That way, the reader will know what the code does and will be able to find references to this variable. Looking for references to a hard-coded number is simply not possible. So let's go to the top of the class and declare a new serialized variable called maxAmmo. Let's also add 2 more variables to remove 2 more magic numbers in the rotatePlayerObject method. Now let's change every instance of assigning the current ammo variable so it's assigned to the maxAmmo value. So in the initialize variables method and in the reload method. In the rotatePlayerObject method, we will change the -90 and 90 numbers to the variables that we created a second ago. And a quick fix here from the previous video, we have to remove the not operator from the has enough ammo check. Back in Unity, let's set our newly created variables in the inspector. Now let's test if everything's still fine, and looks like we didn't break anything and we can move to the next rule. Rule number 2. Avoid complex conditionals. Add intermediate variables or separate methods to clarify the intent. In the handle shooting method, we have an if statement containing 3 separate conditions. It is not easy to read what we are checking here. In such situations, it's better to move the whole statement to a separate method, which name will clearly state the intent. So let's extract a method called checkIfCanShoot. Now it's clear what we are checking in the handle shooting method. Rule number 3. Look for patterns in your code to find duplicates and create methods from them. Let's take a closer look at our shooting methods. Each one of them has the same code at the beginning, which is responsible for playing a shoot sound. We should move this code to a separate method to avoid code duplication. So let's create a new method containing that code in its body. Let's call the method playWeaponShootSound. Now we can copy the method and paste at the beginning of the rest of our shooting methods. The second case is in the code that raycasts and shoots an enemy in the shoot pistol and shoot rifle methods. So let's copy the code and put it in a separate method called shootWithRaycast. And of course we will use it in the second method as well. In order to be also clear what happens in the shootRPG method, let's extract the code below the playShootSound method to a separate method called shootProjectile. And the last place where we can extract duplicated code is in the switchWeapon methods. We are using the same code as in the setActiveWeapon method, so let's remove this duplicated code and simply code the setActiveWeapon method. Now let's go back to Unity and give it a little test. Everything looks okay, so we can move to the next rule. Rule number 4. Variables should be defined closest to their first invocation. In the fixedUpdate method, we are setting values for the moveSpeed variable at the beginning of the method. If we take a closer look, we can see that this value is called at the end of the method. We should aim to have variables with the shortest lifespan possible. That way, reader does not have to keep track of variables that he does not need to. To fix that, we should move the first line of code just above the last one. Rule number 5. Place methods in logical order. Proximity principle. This one is pretty easy. Place method definitions closest to their first invocation. I did it behind the scenes, but if we scroll down, we can see that every method declaration is closest to its invocation as possible. It helps readers to find methods in the class when reading other methods. Also, if a method is declared above some invocations, readers will know that this is not the first invocation of this method. Rule number 6. If a method uses more than 2 or 3 properties from a class, pass the whole object as a parameter. The init method from the projectile class has 3 parameters that are variables from the same weapon object. To simplify, we can just pass the whole weapon object here. Of course, it's better to pass just the values to decouple the code, but when the parameter number grows large, it's a clear sign that the dependency has to be added. And of course, we also need to change the method declaration. Another test is recommended, so as always, back to Unity and let's shoot some people. They go down, so we are good to go. Rule number 7. Class names should describe precisely the function of the class. Their names should not attract methods that don't attribute to the responsibility. This can lead to big monolithic classes that have too much responsibility. In game development, there is a widely spread usage of classes with the word manager in their names. Often they are used in places where it is not correct, like our player manager class. The next rule will help us to fight the urge to create those managers. Rule number 8. Classes should have a single responsibility. Our player manager class is responsible for receiving input, moving a player object, and shooting weapons. We should split those responsibilities to separate classes. So first, let's create a new script called input_receiver. We will need here variables that will describe buttons responsible for shooting, running, and reloading. Next, let's declare constant string variables for axis names, horizontal and vertical for arrow player movement, and mouse X and mouse Y axis for player rotation. Next, we need properties that other scripts can access and retrieve input data from our buttons and axes. In the update method, we want to do 2 things. Receive an input from buttons and receive input from axes. So let's create those 2 methods and call them in the update method. Order is not important here. In the receive axis input method, we will store input from each axis in the proper properties that we declared earlier. Those properties have public getters and will be used by classes responsible for moving the player and shooting weapons. In the receive buttons input method, we will do the same but for the input taken from the keyboard buttons. Back in the player manager class, we can remove the isRunning variable because now we will be able to receive that value from the input receiver class. In order to use the input receiver in the player manager class, we need to add it as a member field and cache in the awake method. Then, in the fixed update method, we can directly ask input receiver if the running button is pressed. We can also remove assigning the isRunning value in the update method. Let's change checking if a player is hitting a reload button from calling the Unity's input class to calling the input receiver class. And same with the rotate player object method, we can get appropriate axes from the input receiver class. We should add 2 more properties for axis input on the mouse scroll, so let's add them. Then assign is scrolling down to true when the Y component of the mouse scroll input is less than 0, and opposite for the scrolling up property. Back in the player manager class, in the handle switching method, we can use newly created properties from the input receiver. Same in the fixed update for the input received from horizontal and vertical axis. And the last place we need to change is the check if shoot button is being pressed. Back in Unity, we need to add the input receiver component to the player game object and set the buttons. I will choose the left mouse button as the shoot input, the R keyboard key as the reload input, and the left shift as running input. One quick fix, we want to receive running input not only in the first frame of pressing the button, but every frame when the button is pressed. Let's test if everything works. Looks like it, so let's take care of the class responsible for moving the player. So let's create a new script called player movement. But first, let's go to the player manager class and group all the variables that are connected to moving and rotating the player object. Then cut them from the script and paste in the player movement class. The rifle transform parent is also connected to rotating the player, so let's move it to the player movement class. Let's cache the rigid body component in the awake method. Then go back to the player manager class and cut all lines or methods that are now marked as errors and paste them in the player movement class. So initializing the rotation variables and the fixed update method. The fixed update uses an input receiver, so let's add a member field for it and cache it in the awake method. Looks like our fixed update method is doing two things here. So let's use the knowledge that we learned before and split it into two separate methods. One that will calculate the move vector and the other that will set the rigid body's component velocity vector to the calculated move vector. Next, cut the rotate player object method into the player movement class, remove the method invocation from the update method in the player manager class, create an update method in the player movement class, and call the rotate player object here. Go back to Unity, add a player movement component to the player object, and fill the inspector variables with similar values as we had before in the player manager class. Another test is in order, so let's hit play and check if everything works. After extracting input receiving and moving player into separate methods, our player manager class is now responsible only for shooting weapons. So we managed to make each class single responsibility, and we don't need to use a magnet word like manager in the class name. So let's change the class name from player manager to player shooting. Now it's time for rule number 9. Make use of polymorphism over enums and switch statements. In the handle shooting method in the player shooting class, we have a switch statement that, based on the weapon type, calls a different shooting method. Imagine we want to add a new weapon to our game. In this case, we would need to add code to the player shooting class with risk of breaking previously implemented functionality here. To avoid that, we should move shooting responsibility to the weapon class and use polymorphism to create different implementations of shooting mechanics. That way, the player shooting would only need to call the abstract shoot method for the currently held weapon. So let's remove the whole switch statement and call still not existing yet abstract method called shoot. Because we will create separate classes for each weapon type, we need to make the weapon class abstract and declare an abstract method called shoot. All inherited classes will need to implement this method in their own way. Back in Unity, create two scripts for two different types of weapons that our game currently uses: the raycast weapon and the projectile weapon. So let's open the raycast weapon script first, inherit the weapon class and override the shoot method. Then we can cut the whole code from the shoot raycast method in the player manager class and paste it in the shoot method of the raycast weapon class. Weapons should also be responsible for playing the shoot sound instead of player shooting class, so cut the play weapon shoot sound method and paste into the weapon class. Every weapon will play the shoot sound, so we can call this method in the base of the shoot method. We are lacking a reference to the audio source component, so let's add it as a serialized field. Back in the player shooting class, we can remove all methods that previously were responsible for shooting. Now we are moving those responsibilities to weapon classes. Next, copy the code from the shoot with projectile method and use it in the shoot method of the projectile weapon class. Just like with the raycast weapon class, we need to inherit the weapon class and override the shoot method. Because right now the code is called from the weapon itself, we don't need to refer to a weapon before using the getBalanceSpawn transform and the getProjectilePrefab methods. Next, go back to Unity, remove the old weapon components from all of the weapons and add the appropriate components. the raycast or projectile weapon. There's another advantage with using polymorphism here. Before, we had to have all references required by both kinds of weapons in the same script. Now we can remove fields that are necessary only for the projectile weapon class and have them only there. So let's cut the projectile speed, projectile prefab, and the impact clip fields from the weapon class. Let's also cut and paste the corresponding getter methods for those fields. Now our projectile class gives us compilation errors because it wants to access data that we just moved from the weapon class. If we think about it, the projectile class should depend on the projectile weapon class and not the weapon class. No other weapon needs to be aware of existence of the projectiles. So let's change the parameter type from weapon to projectile weapon and all errors should be gone. And now we are ready to remove the weapon type enum from our code. We effectively got rid of the switch statements and enums in our code. Now back in Unity, let's fill the inspector values for each weapon. And we also need to reassign our available weapons in the player shooting component. We did some huge changes, so let's give it a test and check if everything works as before. There is one more thing that the player shooting script is responsible for and shouldn't. It's counting the ammunition. Each weapon should have its own ammunition. So let's cut the max ammo and the current ammo variables and paste them into the weapon class. In the awake method, we can assign the current ammo variable to the max ammo value. The player shooting will still need to access the ammo from the weapon class for displaying the ammo value. So let's add a getter method. Now we don't need to initialize variables methods. We can just lock the cursor in the start method of the player shooting class. Let's generate the getter method for a weapon's current ammo number. The has enough ammo has to be moved to the weapon script. Only the weapon should know how much ammo it has left. Let's make it public so we can use it in the player shooting script. The reload functionality should also be moved to the weapon class. Let's remove the time counting from the method. It will stay in the player shooting class. Also, let's move the code responsible for playing a reload sound to a separate method. Let's make the reload method public so that the player shooting class would be able to call it when player hits the reload button. So, in the update method of the player shooting, we will reset the wait time, call the reload method on the currently held weapon and set the ammo text. Now, those three lines are the player shooting reload responsibility, so let's move it to a separate method for clarity. Also, we should move it to the bottom so we don't break the proximity principle that we talked about before. Now that I think of it, we should only reset the time when we shoot the weapon, so let's remove this line of code from the reload method and decrease the current ammo number every time we call the shoot method. Now we need to fill the missing inspector variables in all of our weapons. And now it's time for the rule number 10. Rule number 10. If you have more than 3 parameters in your method, it can be a sign that your method is doing more than one thing. The onEnemyShoot method in the enemy manager class has 3 parameters that don't really go together. Damage is kind of out of place here. If you look at the code, we can see that we are doing 2 things here: decreasing the enemy's health and impacting the ragdoll. So let's create 2 separate methods for those functionalities. Let's copy paste the method, name one take damage and leave just the line that decreases the current health value. The second one will be named impact rigid body and will do the opposite. So just delete the take damage responsibility. Remember to remove unnecessary parameters from those methods. And in the projectile class, call those two methods instead of the onEnemyShoot method. After all those changes, a test is required, so as always go back to Unity and check if everything works as before. And that's it for the next 10 tips on how to write clean code. I left some bad code in the project, so if you like, you can find it and share your thoughts in the comments. I would also like to tell you that my Patreon page is up and running. Please consider supporting the channel. Having funds for outsourcing editing of videos would help me post videos more frequently. You can find the link in the description below. You can find the whole project on GitHub. The link is in the description below. I hope you enjoyed it and please like and subscribe if you like my content. Also leave a comment, I'm happy to answer all your questions. Take care.